removal of stock to bring a piece of work to specified size, shape, and finish is one of the prime functions of the metalworking industry. The machines employed are infinite in character and variety. Milling machines, broaches, lathes, shapers, planers, and so forth, each one designed to remove metal in a particular fashion. Yet regardless of the machine employed, the tools which do the actual cutting have one feature which is common to all. That common feature, of course, is the cutting edge. Sometimes it's just a point, sometimes a single edge, sometimes the tool has multiple cutting edges. But in every case, cutting edges or points remove stock by taking chips as they pass over the work. Probably one of the first metal cutting tools designed by man was the file. Its origin is shrouded in antiquity, but after centuries of use, it still remains one of the most versatile and indispensable tools in the metalworking industry. The modern file is a very efficient cutting tool, but it is also a hand tool. Therefore, its efficiency depends to a large extent on the skill of the user. The purpose of this film is to explain the use of files, how to select the correct file for the job, and the care required to make this basic tool of industry do its most efficient job. These are typical American pattern machinist files used throughout the world in industry, in machine shops, and in repair shops. They are available in a wide variety of shapes, sizes, and tooth structures to fit the needs of the specific job they must perform. Since the file is a cutting tool, let's examine the teeth which do the cutting. This is a single cut file, which means that it has one series of parallel teeth running diagonally across the width of the file. Each tooth is a cutting edge, so a file is really a multi-bladed cutting tool. Under magnification, we can see that the teeth have tiny serrations along the cutting edges. Research has shown that these serrations reduce chatter, resulting in a smoother cut and allowing the file to cut with less effort. Notice that these filings are actually finely curled chips, similar to those from any machine tool. This is a double cut file. It has two series of parallel teeth running diagonally across the surface, one series crossing the other. This double cut results in the formation of hundreds of individual sharp cutting teeth. Under magnification, the structure of these individual teeth is clearly visible. This structure allows the teeth to penetrate the work more deeply and hence remove more stock. The appearance of these chips is evidence of the chip breaking action of the double cut teeth. If we could make the piece of steel we are filing transparent, it would be possible to see these teeth actually cutting chips as the file passes over the work. Now, let's watch this flat bastard file cut once more, again in slow motion. Here, the pressure on the file is light, and while the teeth are cutting, they are not performing efficiently. But as pressure increases, these double cut teeth really begin to cut chips. This flat bastard file, with its coarse teeth, is the one to use for hogging, where the problem is stock removal, not finish. The flat bastard is universally used by all machinists and mechanics. Cast iron filings are powdery. A clean, free-cutting file, free from oil, performs best. This is the most widely used file in the machinist group. It is a thick, rugged file, used for practically all roughing operations. Truly the workhorse of the file family. It would be well to mention here that most files, whether single or double cut, come in 3 degrees of coarseness: smooth, second cut, and bastard. The difference is slight, but can be readily seen in this close-up view. The same difference in degree of coarseness is clearly visible in these double cut files. Files are used on a wide variety of materials, but of prime importance is their ability to cut metals. Therefore, the teeth must be hard, extremely hard. Actually, file teeth are so hard that they will cut glass, but hardness, of course, also means brittleness. It's easy to break a file. So don't use a file as a hammer or a pry bar. It's not intended for that purpose. The purpose of most files is to cut metal, so the hardness of the teeth is a necessity, and means that the file should be used as a fine tool, a cutting tool. Now let's watch an expert do a job of filing. Notice the easy, relaxed stance, and that both file and right forearm are kept parallel to the plane of filing. There is no rocking. For best results, the work should be held firmly so that it won't chatter. Lay the file flat on the work to adjust arms to the correct position. Grip the handle firmly and hold the point with thumb and forefinger. And remember that it is just as important to hold the file correctly as it is to hold a golf club correctly. Waist high is the best working height for comfort. Apply sufficient pressure to make the teeth cut. But too much pressure could spring a file, resulting in a convex instead of a flat surface. This is the correct cycle. File slowly with the file level. Raise it from the work on the return stroke and file on the forward stroke with just enough pressure to make it cut. Failure to raise the file on the return stroke wears the teeth. If you file easily and let each pass of the file slightly overlap the previous one, you'll get a more even and uniform surface. When the roughing cut is completed, a 10-inch single-cut mill file is selected, which will leave a good finish. A handle is the first requirement, for the unprotected tang could cause a serious injury. Notice that the same stroke is employed, cutting on the forward, lifting on the return stroke. Brushing to remove the filings is good practice. Oil is never used in filing steel. In fact, even the oil from a greasy hand that is rubbed on the work makes filing more difficult. Even this new file does not cut well on an oily surface. Don't file a hard, sharp corner like this with a new file. You'll only break out teeth. See what these few strokes have done. Use an old file on sharp corners and on rough castings, too. Some castings have hard spots, sand blisters, and chilled surfaces, which might also damage the sharp teeth on a new file. It's good economy, therefore, to use an old file to remove scale. When the surface scale is removed, it is time to use the new file. Now you can hog it off with this new double-cut file without damaging the sharp teeth.
Repeat this paragraph on page 5.
So far, we've been filing the ferrous metals, but the non-ferrous metals must be filed too. Babbitt, lead, and zinc are soft. The main problem is to get a smooth surface without clogging the file. For these soft materials, we choose a coarse, single-cut lead float or Babbitt file. The wide, deep gullets give ample room for the heavy chips that result from filing these soft materials. It is very important also to keep the file clean on these materials. A wire brush or file card is sometimes required to clean these soft chips from the gullets. Years of research have gone into the design of the teeth on files, so you'll see a difference between the teeth of a file intended for brass on the left and those of a file designed for aluminum. The brass file has teeth nearer a right angle, and the overcut, which makes the chip breaker, is long. The aluminum file has teeth set more at an angle, and the chip breaker cut is shorter. In both of these cases, the small teeth make small chips, which minimize clogging. Here again, the skillful filer files gently. You don't have to press on the file to cut brass. It's good practice also to glance at the teeth occasionally and keep them clean and free cutting. On aluminum, too, easy does it is the rule. Too much pressure may clog the gullets, and clogged teeth scratch the work. A clean file always does the job best. There's a special file for lathe work, too. Compared with an ordinary mill file on the left, the teeth of a lathe file are cut at a much greater angle, so the teeth are longer. Notice also that the teeth are coarser. These long-angle coarse teeth have a shearing effect on the work and minimize clogging by rolling the chips out of the file. This results in a smoother, faster cut and reduces chatter. A lathe file is made of heavier stock than the mill file, so more pressure can be applied safely. Long-angle lathe files have two safe or uncut edges, so they can be used against a shoulder. Although the work is rotating, it is absolutely necessary to maintain the same stroke as when filing work in a vise. This allows the file to cut along its entire length, distributing the wear more evenly and leaving a smooth and uniform surface on the workpiece. This is the multi-cut file. Its coarse single-cut teeth are crossed by widely spaced ground-in chip breakers. The multi-cut, therefore, presents to the work wide coarse teeth for rapid stock removal and smooth finish. Notice the deep, smooth cutting action of these broad, sharp teeth. And notice, too, how nicely the chips are broken up by the ground-in chip breakers. These ground-in chip breakers, combined with the coarse single-cut teeth, make the multi-cut a very versatile file. It performs extremely well on a wide variety of materials. Notice the good finish it leaves on brass. On plastics, too, it cuts clean and free. Machining stainless steel always presents a problem, yet the multi-cut does a real job on this tough, stringy alloy. Much filing is involved on dies and templates with irregular shapes. This piece was made up to demonstrate the various shapes of American pattern files available to do specific jobs most efficiently. On this flat surface, any file of the proper size having one flat side could be used. This operator has chosen a half-round file, for his next surface is concave. But actually, any file having at least one flat side could be used. Draw filing is employed to obtain a smooth finish and a flatter surface. For this radius, a half-round file is indicated, but its cross-section must be smaller than the arc of the depression. Notice the twisting motion that is used with a half-round file in order to maintain the true radius. When the hole is too small for a half-round file, use a round file. A 10-inch round is just right for this hole. This one needs an 8-inch round file. The size of the hole, of course, dictates the file to be used. For this small radius, a 3/16 chainsaw file would be the best choice. For a keyway like this, a pillar file, which has one safe edge, would be the best choice. A safe edge, of course, means that no teeth have been cut in that narrow edge. An 8 or 10-inch square file will be good for roughing out the sides of this square hole. A 6 or 8-inch 3 square is indicated for this shape. For this radius, the right size half-round would be good, but many skilled craftsmen prefer a square file. A combination forward and stroke blends the filed surface to the correct radius. This narrow slot is the place for a warding file. You can't raise it on the return stroke here, but you should relieve the pressure. A knife file is, of course, the only file which could be used here. Here's a place where a larger warding file should be used. Although primarily a saw file, the cant saw file is the best one to use on this shape. The width of the file chosen is important. This one is so wide you can't see the work. A pillar file, which is narrower and has one safe edge, would be better. Notice the twisting motion used to follow the convex radius. Up to this point, we have dealt with files in the machine shop. But in the lumber and woodworking industry, files are also an indispensable tool. Band saws, circular saws, hand saws, cross-cut saws, and chain saws are kept sharp by filing. Their efficiency depends on the skill with which they are resharpened. This filing machine is equipped with a 3-cornered saw file for sharpening the teeth on a circular saw. This file is chosen because it makes 3 file surfaces available before the file must be changed. Simon saw files have been designed to fit the special tooth and gullet shapes of all saws. Grinding marks or hard spots in the gullets of wideband saws, which might result in cracks, are removed by this special gullet file. Sawdust will clear itself freely from this smooth gullet. The narrow band saw file has rounded corners. It sharpens these small teeth and, at the same time, maintains the round gullet to prevent cracking. The cant saw file, triangular in shape, but with one side wider than the other 2, was selected for this pulpwood saw. The flat side sharpens the cutting teeth, while the triangular back fits the raker teeth. This same cant saw file is, by far, the most widely used for sharpening small circular saws. The special saw bit file, single cut with 2 round edges, was designed to sharpen inserted tooth wood-cutting saws. The round edges prevent damaging the gullet, and the uniform width provides more filing surface. The square-shaped single-cut dado file, with its sharp edges, was specially designed to maintain the proper tooth shape and sharp gullet on the cutting teeth of dado heads. A special cross-cut file, equal in width from heel to point, was developed for filing cross-cut saws. This special design gives added filing surface for longer wear. Chainsaw files come in a variety of sizes and shapes. This new double-cut round chainsaw file, with its teeth cut on a spiral, has been designed to give a fast, smooth, free cutting action on the hard teeth of chainsaws. For sharpening a handsaw, this extra slim taper file is selected to give good visibility. It fits the gullet and the front of one tooth, and the back of the adjoining one are sharpened with each stroke. Rasps have a wide variety of uses. These are used in horseshoeing. These are the rasps used by woodworkers, cabinet makers, pattern makers, and so forth. This so-called half-round shoe rasp is widely used in hobby shops, model making, and around the home and farm. To finish shape a large radius like this, a cabinet rasp was chosen. For a small radius, a shoe rasp with its combination of rasp and file teeth is ideal. A rasp is designed for rough work. It should never be used on delicate surfaces. It might leave a bad impression. Two distinctly different types of files are used on bodies. Of course, we mean auto bodies. This group, known as body files, are specially designed for metal finishing. A second group, Vixen milled curved tooth files, are the most useful and efficient files ever designed for automobile body manufacture and repair. They are available in both rigid and flexible type, and in a wide variety of special shapes with holders designed to fit them. The outstanding feature of the Vixen file is its series of deeply milled curved teeth, which are held to close tolerances. The curvature of the teeth and the undercut, or positive rake, together with the properly designed clearance angle, give a shearing action which encourages the chips to break up and move out the sides of the gullets. This shearing action is clearly seen as we watch these milled curved teeth cutting. The uniformity of these tightly curled chips and the smooth finish is prime evidence of the skillful design of the Vixen file. Notice how readily these heavy chips break up and the ease with which they move out of the gullets. For auto body repair work, the Vixen file is unexcelled. It cuts through paint, rust, and solder with equal ease, leaving a smooth surface. A special reveal file does the job on ledges and overhangs and similar hard-to-get-at places. Vixen half-round shell files have teeth on the convex side only. With their special holders, they are designed for use on pronounced concave surfaces. Many unusual contours are found on an auto body, but there is a Vixen file to fit every one. Here, a flexible Vixen blade has been adjusted to a slight contour to file the solder-filled patch on a fender. The design of this rigid Vixen file makes it the outstanding file for the fast removal of stock from the softer metals. Due to its coarse teeth and wide, deep gullets, it cuts free and clean and generates a smooth surface. All Vixen files may be resharpened many times during their long life, an important economic advantage. Rotary files and burrs, available in either high-speed steel or carbide, are power-driven. They are widely used in tool and die shops, aircraft and automotive plants, machine shops, foundries, and so forth, for removing burrs and fins, elongating holes and slots, and finishing small and intricate parts. Here, a carbide burr cleans the sheared surfaces of a punched slot to the desired size and leaves a smooth finish. This broached keyway in a high-speed rotary metal shear is chamfered by a 90-degree carbide burr. These are typical parts which need deburring. Here, an air gun furnishes the necessary speed for work of this type. High-speed steel rotary burrs are also widely used to remove excess stock from hard-to-get-at places on molds, cavities, and hobs and cores where machining is impractical. Power-driven files are widely used on the roughed-out surfaces of dies and templates to bring the work closer to tolerance in preparation for final finishing by hand filing. The files used are parallel machine files. They are designed to cut on the downstroke, thus carrying the chips away from the scribed lines on the die. They belong to the American Swiss pattern family of files. American Swiss pattern files are the fine filing instruments of precision craftsmen. Made in a wide variety of sizes, shapes, and cuts, Swiss pattern files are generally smaller and narrower in both width and thickness than American pattern files. Many shapes taper to a sharp point. These are typical cross-sections of Swiss pattern files. Die sinkers' rifflers come in a wide variety of shapes with small cross-sections designed to meet the die maker's exacting demands. They are shaped to reach corners and crevices of intricate dies and the small contours in irregular shaped drawing and forming dies. For roughing out and finishing the larger contours of small dies, files with a heavier cross-section are needed. Silversmith's rifflers, the heaviest in cross-section of all rifflers in the Swiss pattern family, are ideal for this purpose. Round-handle needle files and square-handle escapement files are used for the delicate work of jewelers and watchmakers, while die makers find them invaluable in finishing the narrow slots in intricate forming dies, where precision filing is a necessity. Hobbyists, model builders, and home craftsmen find many of these Swiss pattern files are ideal for intricate detail work. Throughout industry, machines and machine tools increase in size, in complexity, and in design. But the hand file, one of the oldest tools in the world, still keeps pace and grows in importance as one of the truly indispensable tools of industry. The men who use them are skilled craftsmen. Simons salutes them and pledges its long years of manufacturing know-how to maintain the quality and dependability of Red Tang files.